I like to show is some of my work, building simulation for green buildings, and to show you some example of the project that I'm working on and the project that I finished. Okay. Okay, when you look at this one, this is like a life cycle life cycle view of the building construction. Okay, sometimes you start at the process of 3D visualization. You like to see your building, you like to see the space. Okay, you like to have the computer to do some walkthrough so that you can understand the concept of the space planning. And after that, next. After that, you might want to develop your drawing. You might want to develop your design, your facade, your envelope. And you need to know what kind of material that you're going to use, what kind of glass you're going to use, what kind of shading device, or even though it's going to cost some more. Okay. So the next step you can do with the computer simulation of BIM is the simulation of energy use, simulation of thermal comfort, or even simulation of the lighting, shading, or everything that might affect the performance of the buildings. Sometimes we call this building performance simulation, okay, using the computer. And after that, when you go into the detail of construction drawing, you might want to compare, okay, different materials in terms of what you're going to use between the shading design, okay, between the shading and insulation, what kind of glass you're going to use, what kind of air conditioner that you're going to use. You want to compare this with the performance. Okay, we can do that specification and also go to the construction management. Okay, right now the computer program can help you simulate the construction process. Okay, from the beginning, from the foundation, and what will happen after 1 month, 2 months, or 3 months. Okay, how the construction can proceed during the course of construction period. Okay, you can do that, and after that, when the construction finished, you even put the model in the computer, and you can do the operation. Okay, operation and maintenance. Sometimes we call it facility management. We used to have a special program called CAFU, Computer Aided Facility Management. But right now, with the same model, you can manage everything. Okay, when you really finish, like for example, in this campus, okay, if you have facility management in computer, you can predict what will happen if you have 1 meter of flooding or 2 meters of flooding. You can predict what's going to happen if you have facility management in your BIM. Okay. All right. This is the life cycle of the BIM. You can see that we can apply BIM in every process, from the beginning of the design and to the construction and to the management of the buildings. That is very useful. Okay. Yeah. This is some explanation about what you're going to do with the computer technology. Or I had to say that BIM is not computer program. Okay, BIM is building information modeling. Okay, in the process or in the system, but it's not a software. Okay, it's a process of how you can model the information of the buildings. Okay, so if you start earlier, okay, you start the design earlier with technology, with performance simulation like this, you can save the cost, okay, construction cost or operation cost. But if you start it later, it's going to cost more because you cannot change anything. For example, for the building design, if you select the line building, if you select the good building form and form orientation, shading, you don't have to spend more time on the very expensive glass, window, or air conditioner. Okay? But if you don't have a good orientation, okay, especially in this climate, hot and humid climate, if you don't have good ventilation, if you don't have good orientation, you have to spend a lot of money on good glazing, window, and air conditioner. So if you start the BIM, the process earlier, you try to simulate the performance before you go to the detailed design, before you go to the preliminary design, you start it earlier, you can have some benefit from using beam. Okay, when you talk about green beam, yeah, normally people talk about energy simulation, heat gain, energy consumption. Why you need to predict energy consumption? Okay, because in the near future, you have more stringent energy code, even though in Thailand. Okay, you have to do some calculation, you do simulation for the building to pass the energy code, so it's going to be tougher. Okay. And for the heat gain, you might want to select the right material. What kind of insulation you're going to put in the wall, or what kind of thermal mass you're going to put in the wall. That is very important. And if you want to go for green building certification, this is like a compulsory. You have to do this, and you have to submit the result to building certification, okay, like LEED or a local 3 certification in Thailand. Okay. This one, solar geometry and shading design. Okay. You might want to look at how the building can protect yourself from the solar heat gain, from the radiation. And this is very important because we want to have a high quality working space that can protect you from the sunlight or glare from the daylight. So you might want to do this solar geometry and shading design. Okay. Here, airflow and ventilation. I think this is quite new. Okay, it's not easy, but it can be done right now. Ventilation, airflow simulation. Why you need to do that? Why we need to know ventilation? Because good ventilation means that you can open the window, okay, and you have enough fresh air in the space. That's why you need to know the ventilation of the buildings, okay. And for the airflow, okay, when we talk about airflow, we look at the outside airflow. Okay. Your building, the shape of the building, the form of the building can affect other buildings in the urban area. Okay. That's why you need to do this airflow in and around buildings. Yeah, light and day lighting. Okay, I would say that many people do this lighting and day lighting all the time. I would say that it's not difficult. Lighting and day lighting simulation for the buildings is not difficult. You can do that, and we have a lot of software that can be used to do the day lighting and lighting simulation. It's not very expensive compared to an airflow simulation. It's more expensive. How about it? Load and structural design. I think if you are the civil engineer or structural engineer, you do this all the time. Load and structural design using the computer, okay. Acoustical response. Well, it's not very popular unless you go to special kind of building like auditorium or conference center. Okay. Fire safety. I have some example to show you how people use simulation green beam to simulate the fire direction, okay, flow of smoke inside the building. Carbon footprint. This is very important. You know that when you put something, okay, you used to use AutoCAD, okay, the software that can use to help you draw the buildings, right? AutoCAD, 3D Studios, for example. But if you put in a BIM, like Revit or ArchiCAD, the new software, it will help you calculate the carbon footprint of the whole construction. That's very useful. Yeah, so this is what you need to know, that green beam is not easy, okay, but it's not too difficult. If you have some background about physics, okay, because building physics, building science or building physics, you know about the heat transfer process, you know about material, okay, you've got to know some building physics. Okay. Maybe it's not easy for architects, I know. Okay, mathematics, okay, it's not easy for architects too. Okay. Because when you put something in the computer, you not only put like the shape and form, but you need to know some dimension. You need to know some mathematics. You put some equation in the program sometimes. Okay, material science. Okay, I would say that not many architects know about material science. Okay, they don't even distinguish about the thermal performance of brick wall or concrete wall. Okay, that's the problem that we have. Okay, they know that, okay, this is good, okay, you can use to build a house, but what else? If you change it to polystyrene foam, what will happen? Okay. Environmental side, okay, we have EIA, okay, this is very difficult. EIA means environmental impact assessment. That's going to cause a problem with designer and developer right now. Okay. So you need to know some background on this, and you will know why we have to do that. Okay. Computational side, I said it's very difficult. Okay, for even engineer. Okay, you have to know something computer algorithm. Okay, but if you're not going to be the computer programming, you don't need to know much about this one. Okay, computational side.